You buy a shirt, and the initial fit is perfect. One trip through the laundry later, the hem is riding up and the sleeves are tight. It becomes completely unwearable. Brands routinely categorize this as a sizing issue. They assume the customer ordered the wrong fit, or that the pattern was graded poorly by the designer. But the return data points to a different culprit: uncontrolled fabric shrinkage. It is easy to blame the consumer for using high heat or hot water. The reality is that shrinkage is a mechanical failure. It is engineered directly into the raw textile long before the fabric ever reaches a washing machine. Look at this dimension diagram of a standard 70-centimeter t-shirt. Raw, untreated fabric can easily lose up to 10% of its total length in a single wash cycle. That is a 7-centimeter contraction. A reduction of this magnitude physically morphs the garment from a medium into a small. To stop this cycle of returns, sizing consistency cannot be left to chance. Shrinkage must be managed as a strict, quantifiable specification before a single pattern piece is ever cut. The problem starts on the loom. During knitting or weaving, the yarn is placed under immense mechanical tension to form the fabric structure. Individual fibers are pulled taut, interlocking into a highly stressed, rigid grid. That kinetic tension stays locked inside long after it leaves the machine. That structural tension remains trapped right up until the garment meets a consumer's washing machine. The introduction of water, heat, and mechanical agitation acts as a precise release valve. Water and heat cause the individual fibers to swell and relax. Without the applied force of the loom holding them in place, the entire grid rapidly contracts back towards its natural, unstretched state. This immediate contraction is known as relaxation shrinkage. It is the most severe dimensional drop a garment will experience, occurring immediately upon the very first exposure to water. The structural collapse often continues over time. Loosely knitted fabrics experience progressive or consolidation shrinkage as the fibers swell and entangle, gradually tightening the garment over multiple wash cycles. Because this kinetic tension is baked into the raw material, dimensional failure is a mathematical certainty. The only way to prevent it is to physically reverse the tension before the fabric is turned into clothing. Reversing that tension requires applying an industrial mechanical counterforce directly at the textile mill. This schematic compares the two primary pretreatment methods used to force shrinkage at the mill. On the left, Sanforizing. On the right, compacting. Sanforization is a compressive treatment for woven fabrics like denim. It feeds fabric through moistened rubber belts and heated rollers to forcefully shrink it, limiting post-wash changes to under 1%. Compacting is the equivalent process for knit fabrics like jersey. It uses linear compression to force the knit loops to shrink tightly together while maintaining the overall fabric width. These treatments are mandatory for volatile natural fibers. 100% cotton jersey, heavy French terry, and fleece carry high shrinkage potential if left raw. Synthetic fibers behave differently. 100% polyester and poly blends are heat set during finishing, making their physical structure stable against future dimensional changes. Skipping mechanical pretreatments on cotton to save a few cents per yard guarantees a volatile fabric roll. By the time it reaches the cutting table, the damage is already done. Understanding the physics of shrinkage doesn't protect your inventory unless you legally enforce those treatments in your commercial contracts. Relying on the tech pack to control shrinkage is a common operational error. A tech pack communicates your design intent to the factory, but the purchase order is the legally binding contract. Look at this digital purchase order. Writing a vague phrase like "must be pre-shrunk" leaves you exposed. It provides no measurable standard. Instead, you must write in a rigorous, quantifiable metric, maximum 3% residual shrinkage in both warp and weft directions. Define the testing methodology by citing exact international standards. Use ISO 6330 for global markets or AATCC 135 for garments tested for North America. Without a precise percentage and a specific testing standard written into the purchase order, you have no legal grounds to file a quality claim when a container of undersized garments arrives. Even with an airtight contract, the factory must validate the fabric before assembly begins. The cutting table is the absolute point of no return. Once the fabric is sliced and handed off to the sewing floor, Any unneutralized shrinkage potential is permanently locked into the physical geometry of the garment. A competent factory implements a strict verification workflow. First, they conduct an independent wash test on incoming fabric rolls to verify the mill's data before any shears touch the fabric. Next comes pattern adjustment. The factory mathematically enlarges the graded pattern pieces to account for that allowable 3% residual shrinkage, ensuring the final dimensions land on target. The final safeguard is a standardized wash test on the pre-production sample. This physical garment must pass the tolerance check before the factory receives the green light for bulk manufacturing. Enforcing these sequential validation steps strips the guesswork out of production. You transform quality control from a post-production gamble into a pre-cut mathematical certainty. This flowchart illustrates the complete engineered pipeline. You neutralize kinetic tension at the mill, enforce ISO standard metrics in the contract, and validate dimensional stability at the sample stage. The result is a flat-lined customer return rate. Eliminating this hidden defect protects brand credibility and cuts the operational costs of processing e-commerce returns. This operational rigor has always been the standard in the apparel trade. Delivering consistent sizing at a massive physical scale is the ultimate measure of a reliable supply chain. High-level apparel sourcing does not guess how a fabric will behave after it leaves the store. It mechanically and contractually engineers the exact outcome, starting from the very first thread locking into the loom.